Hello geometry students, I'm really happy to be teaching you another distance learning lesson today. We are actually going to be starting lessons out of the book today. So this is going to be starting with section 1.1. Now these notes are going to be a little bit unusual because we're actually doing two sections today instead of one, because the first two sections of the book both have a lot of vocabulary words and they kind of go together. So at the top, we're just going to write the topic like we normally do, but we are going to write 1.1, 1.2 notes. And as I go through these notes, feel free to zoom in on the picture if you need to see what's on the board better, pause the video, or write down any questions that you want to ask me later. Now in geometry, we communicate a variety of ways. Of course, we can talk about geometry, but a lot of geometry is really visual. So the primary purpose of the notes today is to get down how we're going to draw the vocabulary words that we're talking about. So the first vocabulary word is the word point. The important thing to remember when you're talking about a point is it always has to be a capital letter. The formal definition, and please don't feel like you need to write this down at all, but a point is a specific location in place. It's technically an undefined term. It's only been explained using examples and descriptions, and it doesn't have any actual size. All right, so that's our first word. The next vocabulary word that we're going to talk about is a line. And there's a couple different ways that we can show a line. We can refer to a line as line L. Notice in this case it's italicized and lowercase. Or we can actually draw a picture of a line. If we do draw a picture of a line, then we want to show 2 points on that line. Or an alternative way, and this one has more different variations than most, but we can have 2 capital letters. Notice the arrows on each end of the line. The arrows are there because a line extends indefinitely. So a line is determined by at least 2 points. It's also an undefined term. It has no thickness or width. And again, you're just writing down the words in the picture. All right, the next vocabulary word is the word plane. A plane is a flat surface that extends indefinitely in all directions. It's an undefined term again with no thickness. Now typically when we are talking about a plane, we draw it using a figure called a parallelogram. We can refer to it using a capital letter. So we could say plane J. Now technically the capital letter in a plane is italicized, but I wouldn't worry so much about that part. It's kind of hard to show italicization with capital letters. The main thing is to remember that it is capitalized. So you can write plain J, and there can be a lower, in the lower part of the diagram, usually a capital letter J, or you can show 3 points on that plane. So maybe points A, B, and C, and refer to it that way, plane A, B, C. And I don't want you to worry because we're going to do a bunch of problems that refer to points, lines, and planes these way. And so we'll get more and more comfortable with this as we move along. Now, here's an interesting one, space. You can't really draw a picture of space. There is no picture of it. But the definition is it's boundless in a 3-dimensional set of all points. So left, right, up, down, forward, backwards. Space is just everywhere. All right. Let's talk about a line segment. Notice this is a line here, but this is a line segment. So it essentially means a piece of a line. Now, if you guys were in class, I would have you taking turns reading the definitions, and this would be a lot less boring than listening to me talk. But, we're going to do the best with what we have at this point. So I'm going to keep reading these to you and just ask you to write down the pictures. A line segment is a part of a line that consists of 2 points and all the points between them. So to draw a line segment, it's similar to when we draw a line, but notice, can you see what the difference is here? What's the difference between this picture and this one up here? The difference is that there's no arrows on the end of this one because the line segment does not extend indefinitely. So if either way that we draw it, we do not have arrows on the end. All right, the next vocabulary is coordinates and don't worry about spelling it perfectly, coordinates of a point. When we talk about coordinates, we're talking about the points on a line that can be matched one-to-one with real numbers. So for example, if we're drawing a picture of a line and we want to talk about two coordinates on the line, it might be the first coordinate might be the number 2, the second coordinate might be the number 5. That one will be easier to understand in the context of specific problems. You guys are doing great, and again, I know this, even in person, this lesson is a little bit more boring, but it is important. All right, so now we're going to talk about distance between points, and this is actually kind of important. So let's write the distance vocab word here. When we talk about distance between 2 points, it's a distance between, for instance, point A and B. We write it as AB. Now, can anybody tell what is the difference between this here, AB here, the AB I have here, and the AB I have there? It's a very subtle difference. Some of you may be going, there's nothing on top of it. That is correct. So this is a name, line AB. This is a name, segment AB. This is actually a number. So the distance between points A and B might be an inch, might be a foot, might be a yard, might be a mile. It's a number, not a name. So technically, it's the absolute value of the difference of the coordinates of A and B. So if we were trying to calculate what is the distance between 2 points on a number line, we would take one minus the other. So for example, my number line that I have up here on the board, and I don't know if you can see this, I think maybe you can, the distance between 3 and 1 would be 2, because 3 minus 1 is 2. So the concept itself isn't that bad, it's more being familiar with the terminology that is super important. All right, segment addition postulate. Segment addition postulate. So that's kind of a mouthful. It is the point Y is between points X and Z if and only if X, Y, and Z are collinear. We're going to talk about that in a minute. And XY plus YZ equals XZ. I'm going to write down the basics of that here and draw a picture to go with it, because it really doesn't make sense, in my opinion, without a picture. So let's draw a line with points X, Y, and Z on it. If the distance between X and Y is, say, 5, and the distance between Y and Z is 4, we can add those two numbers together and get 9. So that's kind of a good example of how we demonstrate distance between two numbers. Okay, we've got a few more left. Collinear points. Collinear points. Some of you have played co-ed soccer before. I know that all 3 of my kids did, and they loved it. Co-ed means together, boys and girls together on the same team. So collinear means points together on the same line. So if we were going to draw a picture of that, 2 collinear points might be A and B on the same line. What do you think coplanar points means? Collinear means together on the same line. What do you think coplanar means? Take a guess. Coplanar are points that lie in the same plane. So if we were going to draw a picture of that here, we might have 3 points all in the same plane. All right, a ray. Next one down, ray. Not a ray of sunshine. It is basically an initial point A and all the points on AB going away from A. So when we're drawing a ray, notice it's kind of a hybrid between the line and the segment, because it's got an arrow on one end and a dot on the other. All right? Okay, only 3 more vocabulary words. You guys are doing an awesome job. I know that this is a lot of work. This is a little bit more labor-intensive notes than normal, but this is a foundation for us for the rest of the school year of how we're gonna communicate about points, lines, planes, and line segments. Okay, opposite rays, opposite rays. So opposite rays go in the opposite direction. Let's just draw a picture on it. If point C lies on AB, so let's do the A and the B with the C in between. Don't forget, you can pause this video anytime that you need to catch up with a picture. I just don't want the video to be like 40 minutes long. If point C lies on AB between A and B, then CA, that would be this ray here, and CB are opposite rays. Now, that is just a fancy way of saying, in my opinion, they form a line, okay? Intersect, the word intersect, I'm sure you've heard this before, but it's important for us to clarify. Two or more geometric figures intersect if they have one or more points in common. So if we were drawing two lines and they intersected at a point, that would show their point of intersection. All right, congruent segments are segments that have the same measure. This is our last vocabulary word. We do have a few examples to do after this, but I think this was the hardest part. Congruent segments, let's draw a picture. Let's do a parallelogram and label the points A, B, C, and D. And if I want to show that side AB is the same length as CD, I can put little tick marks there. Now, if you're looking at that in color, it's often in red, but it truly does not have to be. So what I'm going to do is I'm going to describe a couple things, and I want you to try to draw them on your paper, and then I will do that. So the first thing I'm going to say is that point F lies on line ST. Point F lies on line ST. Think about how you might draw that. I'm going to call it example 1. Okay, let's draw line ST. You might just try pausing the video and then giving it a try so you don't have to rush. But if point F were to lie on ST, I could put it anywhere on this line. That would be a perfect example of that problem. Okay, let's try another one. Line ST intersects line AB at P. Let me try that again. Line ST intersects line AB at P. P like Paul. So let's make that be example 2. So if we were going to draw a line ST, we could put an S and a T on the line, and line AB would be here, and we could make P be the point of intersection. All right, I think we're good on that. Now, let's talk about plotting some points. We're going to plot some points and determine whether or not the segments we form are congruent. Let's call this example 3. So the points we're going to plot are A at -4, 4, B at -4, 1, C at 2, -3, and D at 2, 0. If we were doing a bunch of these, I might suggest you get graph paper, but this is the only thing we have to graph, and so we're just gonna, I think, keep running with it here. All right, so we wanna see, is line segment AB congruent to, this is our symbol for congruent, which means the same length, line segment CD. All right, so I'm just gonna kind of do a very rough example of a grid here. Maybe make this a little bit longer. And I'm going to do my x-axis here and my y-axis there. I think I'll go 4 out in each direction. Now, it may be in a while since you plotted points, but to plot the point -4, 4, we would go 4 to the left and 4 up, because the first coordinate is your x and the second one is your y. For B, we would go 4 to the left and 1 up. So that would be our line segment, A, B. Now, to plot CD, we're gonna go 2 over and 3 down for C, and 2 over and 0 up for D. And of course, I did not draw this grid perfectly. But we can count here, and we can see that line segment AB is 1, 2, 3 units long, and CD is also 3 units long. So we would say yes. Now the reason I kind of showed you that example is there is a couple like that on the worksheets, and I thought you might like to see it. Okay, now I'm going to do 1 or 2 more examples here. We're almost done. You guys have been doing great. I'm really proud of you for hanging in there. If you're still watching the video at this point, that's super impressive. It is so much, it takes a lot of effort to learn using videos. Okay, so I'm gonna draw an example now, and we're gonna call this line segment A, B, C. And we're gonna label the distance from A to B as X, the distance from B to C is 2X, and the distance here as 2X plus 5. Now this is a pretty complicated example. This is going to be our last example. So take a deep breath. If you can't do it, it's totally fine. But I'm gonna give you a hint. The hint is that we can set up an equation to solve this. And I'm gonna help you do it. But I want you to remember what we talked about with betweenness of points earlier. So clearly B is between A and C. And again, the distance from A to B is X, and from B to C is 2X. Can anybody think of an equation that we could set up to solve this? Think for a minute what you're doing in this picture and see if you can come up with an equation or the beginnings of an equation. Now, one of the things you guys might like to know is they've done research that shows if I ask you a question and you don't know the answer and then I tell you, you're a lot more likely to remember it than if I just tell you the answer. So that's why I try to ask questions and give you a chance to answer. All right, so here's the equation. We knew from what we learned earlier about betweenness of points, if the B is between A and C, I can take the distance from A to B, which is X, and I can add it to the distance from B to C, which is 2X, and I can set that equal to the length of the whole thing, which in this case would be 2X plus 5. All right, now one thing that might make this a little bit easier to see is to put a 1 in front of that X there. It's kind of invisible. Now, some of you feel more comfortable with Algebra 1 than others. So I want to reassure you that we're going to do a lot of Algebra 1 review in this class, and I'm going to be helping you with that. So if I have 1X and I add 2 more X, that makes a total of 3X. Now I want to get X on its own here, so I'm going to subtract 2X from both sides. This cancels out, and I'm left with X equals 5. So I know that was kind of a hard example to end our lesson with today, but like I said, there's something like that on the homework, and I wanted you to be prepared for it. I'm really looking forward to helping you in Zoom, and don't forget to write down any questions you have to ask me for then. Thanks, guys. Talk to you soon. Bye.